Today we're going to learn how to solve systems of equations using elimination where we have to multiply the equations. So last time we talked about the simple elimination when they already eliminate or we just have to change the signs. So this first one, remember to eliminate. We need one of the variables to have opposite coefficients. Opposite coefficients meaning one negative, one positive, but the number itself, ignoring negatives, the number is the same. So like 5 and -5, those are opposite coefficients. If we have opposites like that, then we can just add the equations together and eliminate that variable. The rest of it we would just add together and then solve the equation, substitute to find the other variable. Okay, this one we see -4y and -4y. If we add those together, we get -8. I want them to eliminate, to have 0, eliminate. So that means one of these needs to be positive. So to get one of them to be positive, we would need to multiply one equation times -1. And it doesn't matter if you choose the top or the bottom. You could just multiply one of them times -1. And when you multiply by -1, that's really just changing all of the signs. So that would make -9x, positive 4y, and a positive 20. It changes the signs of everything when you multiply by a -1. And now the y's would eliminate, and I would add together everything else and continue the steps to solve. The first step is just finding those opposite coefficients. The last class we did those where they already eliminated or we just had to change the sign. Today we're going to look at what if I have to multiply by a different number. So I'm looking here and I don't see opposites and I don't see just the sign that is wrong. 6 and 8, 14 and 7. I think, what could I multiply by to get them to be the same number but opposite? So 6 I can't multiply to get to 8, but I can multiply 7 to get to 14. I would multiply 7 times 2, but I can't just multiply the 7 times 2. I have to multiply the entire equation because we want it to stay equal. And when I multiply by anything, that equation is still the same. It's just a different form. So we can multiply by 2 because they already have opposite signs, a positive and a negative. I can multiply by a positive 2 and that's not going to affect the signs. It's just going to help our 7 become 14. So the top equation stays the same. And the bottom equation, I have to distribute the 2 to all 3 parts. If it helps, you can draw those arrows. I'm going to draw them below so I don't run into my top equation. -12x minus 14y equals -20. And then I eliminate the y because I have positive and -14. It's kind of a mess, but that's -12, so I would get -4x and -16. When I divide, I get x equals a positive 4. Two negatives make a positive. And don't forget, after we find that one variable, we have to use substitution to find the other variable. For substitution, I recommend using one of the original equations. Doesn't matter which one. I'm going to go ahead and do the top. 8 times 4. All I did was substitute 4 in for x, and the rest of that top equation stays the same. And then we get to solve the equation, and we've done a bunch of these. Remember, just do opposites to get the variable by itself. So on this one, I'm going to end up getting y equals -2 after I divide. And then our final answer is always written as an ordered pair. In the ordered pair, x needs to go first, 4, -2. We write it as an ordered pair because this is where those two equations would intersect on a graph. Remember, we did the systems by graphing. That is where those two lines would intersect. Okay, the next problem. Again, I'm looking for opposites. I don't see opposites. I don't see that the signs need to change, but I am going to have to multiply. I could multiply 5 to get to 10, or I could multiply 1 to get to 7. When we are doing elimination with multiplying, you will find that you have the choice of what to multiply by. You could get the same answer as someone else, just multiplying by a different number. It doesn't matter. I would recommend looking at the signs, though. That is important. So if I look, these are both positive, and the y's are opposites already. Since my goal is to have opposites, one positive and one negative, I would choose to eliminate the y. You could eliminate the x, but if I multiply by 2 to get 10, they would both be positive 10. So I would have to multiply by negative 2 to get the opposites. Since we don't really like negatives, I would avoid it if at all possible. Sometimes you have to multiply by negatives, but this one we wouldn't have to since we have the opposite signs already. So I would multiply the top equation times 7. That way my y's will eliminate. My new equation would be 35x plus 7y equals 63. The bottom equation stays the same. I add them together, my y's eliminate. I have 45x equals 45, which means x equals 1. Again, we use substitution into one of the originals. I'll choose the top. 5 times 1 plus y equals 9. And this will give us y equals 4. Ordered pair, 1, 4. Okay, these examples, I'm not going to walk through the whole thing. We would just talk about what we could multiply by. So on this first one, we see 4 and 1, 9 and 3. I have the option, I could multiply times 4 to get the x to eliminate, or times 3 to get the y to eliminate. And when I look at the signs, I have negative, positive, positive, negative. They are already opposites, so it really doesn't matter. It's completely your choice if you want to multiply by 4 or by 3 on that one. The next one, we could multiply by 2 to have x eliminate, or by 2 to have y eliminate. Let's look at that one. If I multiply by 2, since they were both needing the same number, that means something is going to happen. We're going to get negative 2x, negative 8y, negative 6, and the top stays the same. Everything eliminates with this one. So if everything eliminates, that is infinitely many solutions. If our variables eliminated and then my constant did not, let's say that it equaled 6, that would be no solution. But if everything eliminates, that is infinitely many solutions. Okay, next one. I could multiply by 4 for the x or by 2 for the y. But one thing to notice is that they're all negatives. So we want them to have opposite signs. I'm going to have to multiply one of them by a negative. So whichever one I multiply, I could multiply this top one. I'm going to have to multiply a negative something. It could be negative 4 to get the x to eliminate, or negative 2 to get the y eliminate. But it will have to be a negative number to make these positive and opposite from the second equation. And I'll let you guys figure out what to multiply on that last equation. Okay, sometimes multiplying one equation just isn't enough, and we have to multiply both equations. Same idea, just a little bit more thinking to get it set up. So 4 I can't multiply to get to 10, and 2 I cannot multiply to get to 7. So that means we have to multiply both equations. The next step is just deciding what to multiply by. And like I said before, you do have options usually. So I could multiply 4 times 10 to get to 40, and 10 times 4 to get to 40, or 4 times 5 to get to 20, and 10 times 2 to get to 20. That would be common. Or 2 times 7 to 14, and 7 times 2 to get to 14. Look at the signs to help you make a decision. X is both negative and Y is opposite. If there's already opposite signs, choose that one. It will make things easier for you. So I will choose to eliminate Y and multiply the top one times a 7 and the bottom one times 2. That way they both will give me 14 for Y. So my new equation would be negative 28x minus 14y equals 98. And the bottom equation will be negative 20x plus 14y equals negative 50. And I would see that my y eliminates, and I would continue the problem just like we have so many other ones. I'm not going to continue it just for time's sake. The next equation, 3 can't multiply to 5, 2 can't multiply to 5, so I'm going to have to pick something to multiply by on both of them. Notice the signs again, both positive, both negative. That means one of the equations I have to change the sign. So I would just choose the top. There's going to be a negative needed somewhere. And then we get to choose the numbers. I could do 5 and 3 for 15 or 5 and 2 for 10. Doesn't matter. I'll go ahead and do 5 and 2. We would get negative 15x plus 10y and equals negative 10. Notice all of the signs change because I multiplied by a negative. The bottom will be 10x minus 10y equals 20. My y's eliminate, and again I can continue the problem. Just the beginning is a little bit different. The rest is all the same as any other elimination problem that we've done. The hard part is just getting that coefficient to be opposite to eliminate. Sometimes we multiply one equation and sometimes we have to multiply both. Be careful though that we don't always have to multiply. It seems that after we teach multiplying, you guys want to just always multiply. Sometimes the easy ones, like the very beginning of this video, if they already eliminate, don't make it hard on yourself by multiplying. Okay, always look first. Do they eliminate, or can I just change the sign before you start multiplying a bunch of equations? It will still work, it just makes it a little bit tougher on yourself. All right, these four, again, we're just going to talk about what we could multiply by. So 3 and 5, I could multiply by the opposites, 5 here, 3 here to get 15. 4 and 6, we could multiply by 6 and 4 to get 24. But you don't always have to multiply by each other. 4 and 6 also have something else in common. You could multiply to get to 12. So we could multiply this times 3 and this times 2 to have some smaller numbers. Doesn't matter. But also notice they're all positive, so one of those would have to be negative when we multiply. This one, I have opposite signs, so that's good to start with. Then it doesn't matter which variable you choose. We could multiply to get x to be the same at 10 or y to be the same at 40 would be the smallest one to do. I would probably choose x on that one just for smaller numbers. This one, all signs are the same, so we're going to have to multiply by a negative again, and then you can choose what would work. And the last one I'll let you figure out, and you just try to solve all four of these after you multiply them to get some practice.